What's up guys, it's me Sir Ernest, and today we're going to answer or discuss example 1.10.1 of Fowles and Cassiday 7th edition. And here we're going to talk about projectile motion. So let's examine the motion represented by this equation. R as a function of time is equal to I hat bt plus j hat times ct minus gt squared over 2 plus k hat 0. Okay, so here B, C, and G are all constants. So you notice here that the Z component is missing. So that means there is no Z component in this motion. Means this represents the motion of this projectile in the xy plane. So from here we can now calculate the velocity of the particle. So the velocity will now be the derivative of the position r with respect to time. So differentiating this, I, J are constants, B, C, and G are also constant. So we now end up with this expression B I hat plus C minus GT J hat. So from here we can identify that this is the x component of the velocity vector and this is the y component of the velocity vector. So in other words, we can represent the velocity to be the x as x times x component of the velocity plus the y component of the velocity. Similarly, we can calculate the acceleration. The acceleration A will just be the derivative, a second derivative of the position with respect to time, or the derivative of the velocity with respect to time. So in this case, because B is constant, so the derivative of the x component of the velocity will vanish, but this time, but the y component will not. So the end result is the acceleration will now be equal to negative g hat. So in this case, g will now be the acceleration. So you will notice that the acceleration of the particle is along the y direction and it is pointing downward by convention. Okay, so that means if you're going to graph this, if this is your y and this is your x, so let's say this represents the motion of that projectile at time t. Let's say the particle is here along this trajectory. So here we define the position r. The velocity will be tangent to this path. And the acceleration is downward. Okay, so if you're going to calculate the instantaneous speed of this particle, so we just want to, or we just need to calculate the magnitude of the velocity. In this case, this is your x and y component of your velocity. So the instantaneous speed will now be equal to the square root of the square of the x component of the velocity plus the square of the magnitude of the y component, which now be equal to b squared plus c minus gt squared to the 1/2. Of course, you can expand this term, but let's leave it like this. Okay, so this is now the speed, the acceleration, and the velocity. So you will notice that for a projectile motion, just to summarize, the x component of your velocity is constant. The y component of your velocity changes with time linearly, given by this expression. The acceleration is constant and it always points downward. And the speed is equal to square root of b squared plus c minus gt squared. Okay, so that's it. That's your projectile motion. Okay, so thank you guys for watching. I hope you learned something today, and I'll see you guys in the next video. Bye-bye.